evaluate the following integrals. So we start with a double integral. The integrand is e to the y cubed. Now, to figure out which variable goes with which limits, we take a look at the order of dx and dy. So dx is first, so our inside integral is going to be with respect to x. So the limits are going to be x going from 0 to y squared. Then for the outside integral, we're going to have y going from 0 to 1. Now, I don't know how to take the antiderivative of e to the y cubed, but that's not a problem. Because our inside integral is with respect to x, e to the y cubed gets treated as a constant. There's no function of x here, so that means the function is 1. It's just hidden. Antiderivative of 1 is going to give me an x. Then we evaluate it y squared and 0. Take the difference, gives me a y squared. Now our integral is integral from 0 to 1 in y squared, e to the y cubed, dy. Okay, we can do this one. This is a substitution. You let u be equal to y cubed. Du equals 3y squared dy. I isolate the dy, so it'll give me du over 3y squared, and then sub it out. So what I'll be left with is, okay, this is going to be antiderivative with respect to u of 1/3 e to the u. Antiderivative of e to the u is itself, so we just get it back. 1/3 e to the u. I evaluate at 1 and 0, take the difference. E to the 1 is just e to the 0 is 1. Okay, be careful here. You're putting a 0 in, but you're not getting a 0 out. So I wind up with 1/3 e minus 1. Next integral, a triple integral. So our integrand is y squared z. We still need to determine the order of integration. So I just take a look at the order of dx, dy, dz, and then that tells me everything we need. So if we take a look, I have z first, then y, then x. So we just work inside out. Okay, our first integral is going to be with respect to z. So we have y squared z. Y squared is treated as a constant. So I'm taking the antiderivative of z with respect to z. Gives me 1/2 z squared. I evaluated our limits, so it's y and 0, and then take the difference. So I get 1/2 y squared times the y squared that we started out with. So I have 1/2 y to the 4th. Okay, next integral. Okay, this is going to be with respect to y. Everything we have is in terms of y, so we can just go ahead and do it. So we have 1/2 y to the 4th. Any derivative with respect to y, add 1 to the exponent, flip it over. So I'll have 1/10 y to the 5th. And we're going to evaluate at x squared, 0, take the difference. Okay, so you have that. And then this is going to turn into 1/10 x to the 10th. This one, we're down to the single variable case, so it's a straight shot. Add 1 to the exponent, flip over. I have 1 over 110, x to the 11. We're going to evaluate at 1 and 0, take the difference, and that gives me 1 over 110.